Hello everyone. Today under this Ferrous Metallurgy Part 1 paper, we are going to discuss regarding the different agglomeration processes. So first of all, we should be clear about what is a agglomeration generally. So agglomerations means that is the unitation of the different particles to get it in a lumpy form. In our day to coming to our day-to-day life experience, in our day-to-day life experience, everyone of us has enjoyed the taste of that is sweet dish, that is our besan ka laddu. So everyone have tasted that thing. So how this besan ka laddu is formed? So that is formed from the first, we have fried the small particles of the basins, and particles are united together by the help of that is the serum of the sugar. So in that case, what we found in the case of the that laddu, that small air pores are there between that of the particles, and this is our requirement during the agglomeration processes. Now the questions come that how this agglomeration process is going to help us as a metallurgist. Friends, as a metallurgist, we know that we have to deal with a lot of metals. Our work is that we have to take out the ores from the different mines, then we have to process these ores in different furnaces, then only we can purify and get the purer form of the metals. So this is our day-to-day life experience or day-to-day life work of a metallurgist, and we have to deal with a number of metals in a common actually. We are generally, basically we are going to deal with the steel and iron. So how this steel in day to day life, frequently we are going across or coming across this steel, use of steel. So how this steel is produced? First we are taking the iron ore from the mines. That iron ore is now put in a furnace, and firstly it is converted into pig iron. That pig iron is converted into steel in the second step. In the first step, when the pig iron iron ore is converted to pig iron, we are taking the help of a huge furnace, very commonly known, that is called as the blast furnace. That blast furnace, why I have told it as a huge furnace, because you know that that furnace is around 30-meter height. This is the highest, biggest furnace that we are going to do as a metallurgist. So this blast furnace is around 30-meter height, and what we are doing with this blast furnace, we are taking the iron ore from the mines, we are putting the iron ore from the top of the furnace, and generally from 8 to 10 meter from the bottom, we are supplying the carbon monoxide, or we are creating the carbon monoxide inside the furnace. And that carbon monoxide is moving in a counter current direction to that of the flow of the iron ore. And what it is doing, that carbon monoxide is reducing the iron ore, because we know that that iron ore contains iron oxide, and we have to reduce that iron ore so that we can get the purer form of the iron. So that reduction inside the furnace, actually this type of reduction, that means the solid iron ore will reacted with that of the carbon monoxide in the top 20 to 22-meter height distance. So it's a huge task. So whenever the iron ore is entering from the top and it is traveling downward for 20 to 22 meters, it has to react with the carbon monoxide. Now, this is done in a solid state, means whenever iron ore is in a solid state. As a metallurgist, our focus is the economy of the process. So what is economy? Economy is directly related to that of the cost of production. It is also to the rate of production. If concentrating upon that of the rate of production. Rate of production means if the carbon monoxide will fastly react with that of iron oxide, definitely the rate of reaction will be better and the production rate will be better. So we can increase the production rate. So here they thought, if we'll put the iron ore directly from the mines into the furnace after breaking into small particles, what will happen? This reaction rate is little slow. Why? Because this iron ore is a compact one. It is a dense one. The carbon monoxide is only reacting on the surface. It is unable to penetrate into the material. That means that reaction is only confined on the top surface of the individual particles. So the metallurgists thought, how can we increase the rate of reaction between that of the gaseous carbon monoxide with that of the iron ore? So they thought, can we convert the iron ore into a spongy form where number of pores, interrelated pores will be there? There the concept of agglomeration came. So they thought, break or cross the iron ore particles into small particles, and we have to unite those particles, that is the agglomerate. We have to agglomerate or unite the particles so that the resultant mass will be spongy in nature, and whenever it will come across the any gaseous substance, the gas will react on the surface as well as it will enter into the material. So the rate of reaction will be better, so production rate will be better. So in context to that, actually number of processes came under the agglomeration. The first process developed was, this is the briquetting. Second process developed was the nodalizing. Third one is the sintering, and lastly pelletizing process was developed. So what is this briquetting process? Briquetting process is a word comes from that of a brick or a block. How we are making? Here we are taking the small particles. We are crossing the iron ore collected from the mines. That crossed particles are put in a block along with that of a moisture as well as the binder. In the case of binder, we can use either that is bentonite, we can use lime, we can use tar, we can use that is sodium silicate, magnesium chloride, whatever the binders you prefer, you can take these binders. With the help of the binder as well as the moisture, that mixture is put in a small block and they are pressed, and they have taken out from the block because they are now attached with each other by the help of the binder and butter. So the bond is not strong. So we have to fire it in a tunnel kiln to a temperature of around say 1350 degrees centigrade. So what will happen? The particle will strongly bonded with each other and the strength of the material will increase. But this thing has failed because here due to the porosity, lack of porosity as well as little dense in nature. Then the second process comes, that is the nodalizing process. Here it is little different, that here again we have taken the small particles of the iron, that means iron ore is crossed, then it is mixed with a carbonaceous material like that of the tar. The mixture is put in a rotary kiln, and that rotary kiln is around 30 to 60 meters. And we are now putting the material at the top portion of the inclined plane, and this inclined plane is rotating at half rpm, and this material is coming down. It takes around 2 hours to cover the entire length of the rotary kiln. Whenever it is traveling, small balls, due to rotating motion, small balls or granules of this material, the iron ore, will form due to help of this binder, that is bentonite or as well as tar. So from the bottom of the rotary kiln, we are supplying any gas or oil, burning that gas and oil, and it is helping to develop high bond strength in the material. And after 2 hours, we have generated lot of nodules of the iron ore. But again the same problem came. That means high dense, lack of porosity. That's why this is also rejected. Now the process developed is called as the sintering process. And this sintering process is better comparison to that of the briquetting as well as the nodalizing process. Here, what is this sintering process? This sintering process, generally in this universe, number of machines are there, but universally we have accepted the DL sintering machine, that is dual lead sintering machine. Here I am giving you the this is our sintering process. Sintering process, here also the process, in this process what we are doing actually, now we are heating a mass of material, mass of small particles into a stage of incipient fusion. What is that incipient? It's a vital word. Incipient fusion means only the surface of the individual particle. Suppose this is a particle, surface of the individual particle will melt, not the entire material. only surface will melt and they will attach with each other. That means a strong bond will develop between these particles. And this is the process how we are executing. For this we have taken universally, we have accepted the DL sintering machine, that is the duet layer sintering machine. Now we have this is our DL sintering machine. So what is this DL sintering machine? Here actually a endless belt is used. Endless belt is used, and this, because why it is called as endless? Because both the ends are joined and it is rotating over the two huge pulleys. Out of these two pulleys, one pulley is attached with a motor, so that when the motor rotates, the pulley rotates and the belt travels over this. The belt is moving from our that right to left, like this. From that side to this side, the belt is moving. And what we are doing, that here there is a center charging cooper. So here we are putting the iron ore particles. We have taken the small particles of iron ore. We have put the iron ores over here so that a bed of iron ore will be gathered over the belt. And this is traveling. The belt is traveling as well as the bed of the iron ore is also traveling towards our left. So what happens here, the ignition hood is there. Is it okay? So what happens here, we have tried to ignite the iron ore. Here we have ignited the iron ore. And another provision is there. This belt is not a solid belt. This is a perforated one. That means small holes are there in the belt. But the iron ore cannot pass through this. So we have gathered the iron ore. We have ignited at the top. How the fire will cover the entire bed? Here a suction chamber is there. Sorry. Here Here actually some air suction chambers are there. What we are doing that, now we are trying to soak airs through these chambers by the help of a turbo blower. So what will happen? In our day-to-day life, we have seen that we have some people are smoking cigarette. So cigarette, in the tip part of the cigarette, we have fired the tip part of the cigarette, and when one is sucking the air through that, the fire is coming towards his mouth. Gradually it is coming in a inward direction. Similar case here, whenever the we are soaking the air through this chamber, the air is from the atmosphere, it is passing through the bed as well as the fire will cover the bed. And by the time the material will cover the entire useful length, this is the useful length of the belt. Whenever it will cover the entire useful length of the bed, by this time the sintering is over. That means the particles have joined with each other by the incipient fusion. That means they have joined with each other, and here a just cake like structure is formed, and this cake will be fall upon this pulley. And here a arrangement is there. That arrangement is called as the sinter breaker. So it will fall in the sinter breaker, and the sinter breaker will break it into different size of the particles. Sinter breaker. So what will happen? Now we have to collect the required size. So what we have to do? We have to arrange a screening facility over there. So screening facility is attached with here. So what will happen? It will separate the oversized particle, it will separate the undersized particle, as well as it will collect the required size particle. So required size particle is okay, because this is our requirement. We will now take this to the furnace. But what will happen to that of the undersized particle? So undersize is little smaller in size comparison to our required thing. So what will happen? That undersize will put in the sinter machine again. So what will happen? Again they will get a chance to unite. They will build up again. The size will grow and will break and will collect the required size. This is for the undersize. Part of the oversized particles. What we have to do? That oversize has to be broken to get the required size. So what we have to do? that oversized particle will put again in the sinter breaker. The sinter breaker, and again it will break and the required size will be collected. Here a suction chamber, through this suction chamber we are collecting the air or soaking the air. So along with the air, small dust particles or small particles of the iron ore can enter. So there is a chance that that turbo blower may choke. So there is a provision that we are changing the direction of this air, outgoing air, so that the dust particle will settle and free air will pass through the turbo blower, so that the process can be continued. So this is the sintering process. By this we get the required spongy shape. So whatever the spongy shape we required, we got by this process. So whenever we are coming to the sinters, I have given you the diagrams of the sinter. This is the sinters. It does not have any particular shape. It is irregular in shape actually, but it is porous in nature, so that the gas can enter whenever it is reacting with any gas. Gas can react on the surface as well as it can enter through the interrelated pores present inside the sinter. So this is the thing. So this is the figure of the sinters. Now we are, and this is a very vital process in almost all blast furnaces. We are going to recharge the sinters. Now another question arises. So in the beginning step of the sintering, first we have collected the iron ore from the mines. We have broken it into small pieces. That means we have done the crushing operation. During crushing operation, we have collected, after crushing operation, we have collected the small particles of the iron ores. But during this crushing operation, we cannot give guarantee that no fines will be generated. Definitely some fines will be generated. So what to do with these fines? They cannot be sintered. So can we consider it as a waste material? No. As a metallurgist, economy, I have told you, economy is a vital factor. We cannot consider this material as a waste, because lot of fines will be generated during the primary stages of the sintering. So what we have to do? So metallurgists thought, can they use these fine particles? So for this they have developed a process that is called as the pelletizing process. What is this pelletizing? Pelletizing process is generally used for very fine particles. Say around whatever the fines generated during ore dressing operation, that is around less than 0.05 millimeter size, that particles can be used during the pelletizing process. So that means here again we have to unite these fine particles and we have to present in a small, that is granular form, or say as in a form of the nodular form, small balls. Is it okay? These are called as the pellets. So how we can do this process? So for this we can go for this pelletizing process. So this is the definition of the pelletizing process. Here we are going to use very fine ore particles, that is less than 0.05 millimeter size. Now what we have to do with this pelletizing process? This process, first it starts with the feed preparation and green ball production. Means first we have to convert these fines into small balls, that is the nodular form. How can we convert? For this we have to take the help of any binder. Preliminary stage we have to take the help of binder as well as the little moisture. So we have taken the iron ore, we have mixed the binder, we have spread little butter or moisture, and we have, by rolling operation, by taking the help of a machinery and by rolling operation, we have converted it into small balls. But these balls are called as the green balls. Why these are green balls? Developed, because they are attached, the individual particles are attached with each other by the help of only binder as well as the water. Here we can take the bentonite or tar as a binder. So and after that's why it is in a wetted condition. So this is called as a green ball. So we cannot use this ball in the furnace. So again we have to go for the green ball drying operation. First it will be dried, then it will be heated to little higher temperature, preheated, then it will to fired to a temperature of around 1200 to 1300 50 degrees centigrade. Here we are producing the balls of around 8 to 10 millimeter diameter size, these balls. And after firing to 1300 degrees centigrade or 1350 degrees centigrade, again it has to brought down to room temperature. That means we are doing the cooling operation so that it can come to usable form. Is it okay? Now the question arises, how these green balls will be created? And this part we are taking the help of a furnace. So by the help of the furnace we can do this heating operation. But this green ball production is done with the help of a machinery. And this is the line sketch of the pelletizer. So this is a line sketch. What we are doing? We are generally preferring a disc pelletizer. What is this disc pelletizer? Here a disc is used. This disc is around 2.5 to 3.5, 3.6 meter in diameter, and it is kept at an inclined position of 45 degree with the horizontal. It is attached with a motor. This motor can rotate this disc at a rate of around 15 to 30 rpm. Here the disc can rotate, and here scrapers are provided so that whenever we will add the material at the bottom of the disc, it will be these scrapers are helping to carry the material to the top of the disc. Now what are the materials we are going to use? We know that we are going to use the iron ore fines. These iron ore fines are put in a mechanical vibrator. What we did here, we have added the required additives like that of the tar or bentonite, whatever the additives we decided we have to add over here. So we have, suppose we have selected the bentonite. Bentonite powder is mixed with that of the, is put along with that of the iron ore fines. Here a mechanical vibrator is there so that it will mix the binders properly with that of the iron ore. And another arrangement is here, that is the water head is there. Here we can spray water in a atomized form. In a very small droplets we are spraying water over the material. So what is happening, that disc is started rotating with the help of this motor, and here we are adding the material slowly. Whenever this material will carry to the top, this by the help of this water spray, small granules will form, or nucleation of the granulation will start. Here small seeds, we can say seeds, small seeds will form, and whenever it will come to down, it will encounter the iron ore particles, fine particles, and the growth of this seed takes place by the layering. By layering, the growth takes place. Again, it is going to top, water will be spread over the particle, again it is coming down. Now in this way, after some times, it will grown up to small balls. But it has, strength has not been developed. Now these balls are screened. Undersize is taken for the re-pelletization, and the required size is taken for the that is drying and preheating process. In the second step we are going for the, that is after the production of the green balls, integration plant, what we are doing actually, now we are first drying provision is there, we are drying the material, that is drying the pellets. Then these pellets are put in a furnace, slowly the temperature will raise. That means in the preliminary part it will be preheated, then it will heated or fired, and the ultimate temperature is around 1200 to 1350 degrees centigrade. And then the strength, bond strength of adequate bond strength can be developed, and the material will again, by switching off the furnace, the material will cool down, and we have collected the these pellets. So these pellets are little porous in nature, but we cannot use these pellets in the case of the bigger furnaces like blast furnace. But these pellets can be used in small furnaces having a height of 8 meter or 7 meter like this, or 5 meter like this. In that furnaces we can use. But here, by the development of this pelletization process, we can use the iron ore fines generated during the ore dressing operation. And I have shown here, these are the pellets, and these are just like the small balls. and for this we have generally used the displetizer. This is the photograph of this displetizer. And regarding this agglomeration process, for any further query, you can follow this site on NPTEL. So you can refer this site and more information you can get out of this. Okay. So here we ends our process. Thank you all.